All right. So we're going to take all those things that you guys did really, really well at on your quiz yesterday, the sine and cosine of the special angles on the unit circle, and we're going to use that to be able to get a graphical representation of the sine and of the cosine. So what we're going to do first is start with the sine. And so there's just selected values from that unit circle to help us get a pretty good graph. And so what I want you all to do for a second is fill in the values on this table. So the input value is going to be the angle. The output value is going to be what the sine of that angle is. And so on the unit circle, if we're given the sine, do you use the x or do you use the y? Yep. So you guys go ahead and fill those in with those y values, please. All right, so now what we're going to do is take those and graph those order pairs. So one thing that you need to know, I know you all aren't using a calculator, but the square root of 3 divided by 2 is approximately 0.688. So that'll help you know where to graph it. And I do, or 866. It's like I said, it's an off day. That's not going to be the last time I say something wrong. But that is important. It's 0.866, not 688. Okay. So one thing that's not on the table that we need to know is the sine of 0. So what is the sine of 0? 0. Good. All right. So we'll start there, and then we're just going to graph all of those ordered pairs. Right, and then we're gonna connect them. This is I'm not doing good with smooth, but this should just be like a smooth, rounded curve. All right, so that is one period of f of theta equals sine of theta. Does it look kind of familiar to you? Like you've seen it before, like every day that week we did these guys? It's basically that same graph. And it's going to repeat this cycle over and over and over again. All right, so here's some information about the graph of f of theta equals sine of theta. The midline of all of these graphs is going to be halfway between the maximum and minimum values. And so for the parent function, we're talking about it's just y equals 0. The amplitude is going to be the distance between the midline and the maximum. And so in this case, that amplitude is 1 unit here. It's also midline to minimum, 1 unit. The period is how long it takes to complete one full cycle. So this one completes the cycle in a distance of 2 pi. And then the frequency is another way to represent a horizontal compression or stretch, but it's always going to be the reciprocal of the period. So what it's saying is that this does one cycle in a distance of 2 pi, which is the same thing. It just says it in a different way. And the graph of sine is going to oscillate between concave down and concave up over and over and over again. Down, up, down, up, down, up. All right? Okay, let's do the same thing for this cosine. All right, so we still have this unit circle. This time our output values are going to be what the cosine of theta is. So we're going to make sure we use these x coordinates each time. All right, so that is what one period of cosine of theta is going to look like. So it looks similar to the sine. It's just a different portion of the graph. So I try to help my students kind of remember which is which. I say that the cosine graph kind of reminds me of Texas Longhorns. So it's like, I don't know, that shape. That's what it reminds me of. So. All right, and so the information, this is going to be the same. So the midline is of this one is still going to be the line y equals 0. The amplitude is still going to be 1. Period 2 pi, and then frequency is 1 over 2 pi. And it's also oscillating between concave down and concave up. Okay, and so both of these are considered sinusoidal functions. So a sinusoidal function is any function that involves the additive or multiplicative transformations of the sine of theta. So even though cosine is its own function, it is a transformation of sine. So if we took the sine curve, and because it does keep on repeating the same pattern. Oh, I didn't mean to do that. It keeps on repeating the same pattern. But if I took it and I shifted it pi over 2 to the left, it's going to give me the cosine function. So the cosine is a transformation of the sine. And this is what the graph is. Like those are the exact same graph. Okay, and so we will talk a lot about transformations next week. But today and tomorrow, I just want us to focus on looking at the graphs and determining these 4 things: the period, the frequency, midline, and the amplitude. Okay, so what I like to do when I have a graph is just go ahead and highlight or like underline or whatever a full period of whatever graph it is. So this one, a full period is this section right here. Does that look like the sine curve or does that look like the cosine curve? That looks like a sine curve. All right. And so it completes that full period in a distance of pi. All right. Now the frequency is just going to be the reciprocal of the period. What do you guys think the midline is? 3. And so we're going to do our midline as the equation of a horizontal line. So it's going to be y equals 3. All right, and then the amplitude is always going to be the distance from the midline to the max, or if you wanted to do from the midline to the min. So what is that distance? From 3 to 6 is 3. Yep. So you're going from 3 to 6, that's 3 units. Or from 3 to 0 is 3 units. All right. Any questions on that? We're going to do some more. All right. Let's look at example 2. All right. So I'm going to highlight one period. Does that look like a sine or a cosine graph to you? Yeah. So that's a period of cosine. How long did it take to complete? Pi over 2. Good. All right. And then the frequency is just going to be the reciprocal of that. Now, this is a good one to help you really understand what frequency means, because when I said it before, I got a bunch of weird faces. But what this is saying, this frequency is saying there's 2 cycles in a distance of pi. And you can see that. Here's 2 cycles in a distance of pi. That is what the frequency tells you. What would you guys say the midline is? It's not quite as obvious on this one. It is 1. All right. If you can't see that, or if maybe it looks like it might be at a fractional point, to find the midline, you basically just find the middle between the max and the min. So anytime you want to find the middle between 2 numbers, you just add them together. Sorry, I got the wrong one. You're going to add them together and then divide by 2. So that's going to be 1. So it'll be 2 over 2, or just 1. All right. And then the amplitude is going to be however much the distance is between that middle and the max. What do y'all think? 2. Right. Any questions on that? Okay. Now, sometimes you don't have the graph. Sometimes you just know 2 points. And I am a very visual learner or talker. And so I need to draw this to be able to talk about it. It's possible you can just kind of figure all this out in your head. I don't know. So anyway, what we know is that the sinusoidal function h of theta has a maximum at pi 8. And the first minimum after reaching this maximum occurs at 3 pi negative 2. So I'm going to come over on the side. And I'm just going to do a little graph. So this is my theta axis. And I know when theta is pi, I have a maximum up whenever h is 8. And then I know that when theta is 3 pi, I have a minimum down here at negative 2. All right. Is that a whole period? What is it? How much of a period is it? Don't know. It's half a period. So max to min, whether it's cosine or if it's sine, max to min is always going to be a half of a period. So how long is a half of a period? Right. So this graph or this function is a half a period in a distance of 2 pi. So from pi to 3 pi is 2 pi. So a whole period, like he said, is just going to be twice as big as that. You double it, it'll be 4 pi. All right, and then the frequency is going to be the reciprocal. And then one like this, that might be a really good time for you just to use the formula to find the midline. So we just take the y coordinates of the max and the min, add them together, and divide by 2. So you're like finding the average of them. So that's going to be 6 divided by 2, or 3. Y equals 3 is your midline. And then once you get the midline, to find the amplitude, you can take the max and subtract the midline, or you can just do it in your head, whichever one you want to do. That gives you the amplitude. All right, so what questions do you guys have so far. Okay, this last question should look familiar. This was the exact question or the exact situation that we did the very first day we talked about Unit 6. And so we have this clock. It's mounted to a vertical wall. The minute hand is 8 inches long. So I'm going to go ahead and start labeling. All right, and the center of the clock is 120 inches directly above the floor. Okay, I'm gonna hold off on the rest of that for now, and I'm just gonna go ahead and label some stuff on the graph. All right, so it told us the center of the clock to the floor is 120. So the center of the clock to the floor is gonna be the midline. What do you guys think about the maximum distance? 128. Yeah, we add that. This I should have finished the problem, but this function is giving the distance between the tip of this to the floor. So the farthest away it's going to be is at 28 inches. Whenever it's pointing at the 3 and the 9, it's going to be the 120. What about if it's pointing at the 6? 112. Subtract that. So basically, you're subtracting the amplitude. Okay, so at t equals 0 minutes, the minute hand is pointed directly at 12. So is this gonna be a situation where I draw our vertical axis at the maximum, or is it gonna be one when it's gonna be at a minimum or at a middle? It's gonna be at the maximum. It's the farthest away at time t equals 0. Oh, super straight line over there. Okay, now this is a funky minute hand because it's going too fast. So it does a full rotation in 30 minutes. So maximum to maximum is going to be 30 minutes. All right, and then we find all these halfway points. This is exactly what we did on that first day. And then we can find what these ordered pairs are. Now, these are not the only order pairs. Your y values do have to be these y values. There's no other option for the y values, but there's someone in particular in my other class that he doesn't start at the beginning he doesn't start at 0. Like he doesn't even draw his vertical axis. He'll say this is the end of the first period, so he would make this 30 and he would make this 60 and do his halfway points there, and he's 100% right. It's just he's doing a different period, so it doesn't matter. I feel like this is easier, but for some reason his brain automatically goes to the other way, so I'm not going to stop him because it's right. Okay, so what we want to do, B and C are different from what we did on the original day. So we want to find the period, frequency, amplitude, and midline. I'm going to keep it in the same order that we did it originally. So period, frequency, midline, amplitude. So you guys go through and fill in what you think those are, please. Okay, and then part C, we're going to find two intervals of the graph of H that are both decreasing and concave up. All right, so decreasing and concave up looks like this. So there's one of them. And then we also have one here. So we're going to have to extend our horizontal axis a little bit. So what do you think this point should be? Or either one of them. Do y'all know? Yeah. This one's going to be 45. And then this one's going to be halfway between, which is 37.5. So there's different ways you can think about it, but from minimum to minimum is going to be a full period, which is 30. So you can just add 30 to 15 to get that 45. Okay, so our two intervals of decreasing and concave up are going to be from 7.5 to 15 and from 37.5 to 45. Thought these things were over. They're not over. All right, any questions or what questions do you guys have?